what I'll be talking about today is the network assurance and verification feature set within the vRealize Network Insight. The idea of this is to be able to continuously validate business policies, the high-level goals of the business and the network and the applications as they relate to the network infrastructure across virtual, physical, multi-cloud networks, the whole thing. The ability to do this comes from a pretty exciting area of technology that hasn't been applied traditionally to network infrastructure. And that comes from an area of computer science called formal verification. So formal verification is something that's been leveraged in other industries with a lot of impact in microprocessor manufacturing and aerospace. So NASA, for example, is a leader in formal verification. They verify the flight software of their Mars rovers before launch, make sure there are no race conditions or other bugs. And what's exciting here is taking that mathematical analysis technology and applying it to network infrastructure. So we want to be able to understand the network in a way that's proactive, a way that that understands the high-level goals, not just the low-level box-by-box, device-by-device details, that understands the whole network. So we are helping our customers move from more of a reactive posture to a more proactive posture in their network management and operations. So let's get a little bit more specific about what this is and a little bit more concrete. So our customers have on-premises networks, they have multi-cloud networks with multiple vendors across traditional vendors, also overlays and underlays, and all of this infrastructure needs to work together. That has a lot of complexity, of course, a lot of moving parts there, and it's hard generally to understand whether the right thing is happening, whether the right thing continues to happen as you make changes in those kinds of complex environments, and especially as you move more to a cloud-based world. One of the reasons to do that is to be more agile, to be able to deploy and update applications more quickly. And so the whole world is changing more quickly than we expect. So being able to understand that the right thing is happening in a rapidly changing complex environment is pretty difficult. So to do that, we collect state and configurations from those network devices. So this is part of the overall network insight data collection process. And for this feature set, though, what we're focused on is state and configurations. That's like routing tables, ARP tables, MAC tables, and so on, but not in this feature set data flow, not live data flow, because we're trying to be proactive. We want to understand what would happen for any traffic that could arrive in the system. And so that analysis is done on the platform to build a unified model. You can think of it as a kind of digital twin, but it's a mathematically analyzable digital twin model of the whole network that abstracts away all the complexity, all of the many different vendors, models, and even types of technology that exist in the network. All of that, all of those details are our job to understand, so it gets abstracted away, and there's a clean model to work with that you can do many different things with. In particular, using that model to mathematically verify network state and intent.
Hey, Brighton, this is Jeremy. I got a question for you here.
Yeah.
Actually, two, maybe three.
Sure, as many as you want.
Yeah, the first one is in this collection process, is it a continuous analysis of information, or is it a snapshot based kind of process?
Yeah, that's a great question, and that can be adjusted. It's about a 10-minute interval of data collection, and currently a 30-minute interval that the models are built. A snapshot of the network that then gets analyzed for intent verification, for example.
Okay, so we'll call it fast snapshots, perhaps, or a high period. But
And we're bringing those intervals down over time. That's getting faster and faster, and dependent on the context. There's some cases where you don't want it to be extremely fast because devices wouldn't be able to handle it.
And these devices, are they, are traditional networking equipment vendors from, the Cisco's, Aristas, Junipers, or are these specifically software, the software products that come from VMware? I'm not so familiar with.
Both, yeah. So NSX, virtual networks, also physical networks, routers, switches, firewalls, load balancers, that sort of thing. Yep. And part of the problem here is you have to understand how those work together.
Okay, and then last question, from the types of things that are collected, I see, what's on the slide here, but is there a data sheet that kind of covers, more information than this? For example, I'm particularly interested in multicast. So, the various multicast protocols and how they interrelate, would it be of interest to me? But I'm curious if it's more than just what you're showing on the slide.
Yeah, we do have full data sheets. I don't believe we currently support multicast, although if anyone that knows otherwise, please correct me. But that support both for devices, vendors, and also features like we talked before about IPv4, IPv6, multicast. Those are constantly being expanded every release, and we do have full data sheets online.
Okay, and last question, is there kind of like a scale or deployment kind of guideline for rolling out these collectors? So for example, I might have 80 sites, and each site might have 100 pieces of equipment that I would want to be running collectors against. Would that be, a collector per site? Is there some kind of, there's only so many devices per collector because of the collection processing? What are we looking for? What are we looking at in terms of, the deployment of this collection technology?
You could deploy a collector on each site. I don't know if Matt, if you'd like to comment on what are common deployments in those scenarios.
Yeah, so absolutely. So with the deployments that we see, typically what we'll do is deploy a collector on a per site basis. So if let's say I've got multiple data centers, I'll drop a collector or multiple collectors, depending on the level of scale we want to go, to be able to, or within each one of those, that provide the connectivity back to the platform appliance to feed that data, because that's where we're doing all of our data collection, deduplication, aggregation, and so on, and reducing the amount of data that actually gets sent to the actual platform. We do have some customers, though, that they don't care about the bandwidth and so on between the collector and the actual platform. So they'll actually deploy the actual collector in their primary data center and add all of the data sources in their secondary, and just pull the data over their direct connector, their whatever they may have from a connection between their data centers, the data center connects. So we can support both models. We have a latency, obviously, that we need to be within, from a round trip time between the collector and the platform, but we can actually do both models as far as deploying the collector.
Got it. Thank you.
And that customer slide that I showed, I think they were north of 30 collectors probably, but their scale, because they have both physical, virtual, the flows, and so on and so forth. So just FYI.
Another question on this vein. So I know that the vRealize doesn't support v6, when Chris asked earlier, but does this support these collectors, the VRNI collectors? Do they support looking at v6? I see ARP tables. Does it support neighbor discovery tables?
I can take that, Brighton. So this is part of the vRealize network insight, right? So it's no different than the ones that Matt talked about before. It's all part of the same product. So when I mentioned it's on a roadmap to get v6, so whenever we have that, these will be included as well. So it's not a separate product. It is bundled in. It is packaged with vRealize. So it's everything that vRealize does will pick up that support as well.
Okay, so no, then.
Yeah, not right now. Yeah, but Brighton, if you want to add anything on that, if right now if we have v6 support on the Mac table itself, but I just.
No, I think that summarizes the current situation.
Yep.
Does the platform, allow you to do the what if kind of questions? It's like, will it route, is the kind of the, will it route in my network, you put in 2 IP addresses or whatnot, and it says, oh, this will route or won't route, and it won't route because of this firewall that's sitting in this path or reasons, is it that kind of a product, or should I just wait for the demo of the platform?
Yeah, we'll see it in the demo, but to answer your question, first of all, this is doing post-deployment verification. Meaning you're looking at the state of the infrastructure as it is. You don't have to wait for flow to arrive. So if you want to ask a question about a possible flow, maybe it's a potential attack vector that you're interested in, or a potential application deployment, you can ask those questions and see how they would be handled by the current infrastructure. So that's letting you be more proactive. Even more proactive than that would be, I'm planning to make this change to routing configuration or to access control. What will happen before I deploy that in the network? And those kinds of technologies are coming, but not in the current product. So we're the Veriflow product, which led to this technology, had that capability to be able to understand access control changes, for example, pre-deployment, and we're rolling in those capabilities step by step into Network Insight. So there's 3 key use cases that you'll see in the demo. Network-wide visualization. The first is to be able to see your whole network, to be able to visualize the topology and see the context of, for example, how the overlay and the underlay fit together. Be able to perform interactive searches in a powerful way for entities and see problems as they appear in different parts of the network visualized. You can use the network model and the verification capability for troubleshooting as well. Something happens to an application, but you need to know how the application relates to the infrastructure, and you can see and ask those questions with interactive path search. You can see events related to particular paths, and there's a very powerful capability of tracing the provenance of a particular behavior. You see this behavior, what caused it? We can actually go back to, well, why does the model think that happens? It's because of this line of a configuration file, and that gives you the root cause you need to adjust if, for example, there's an access control problem. And intent verification is the mathematical capability of defining intents, business intents, and verifying that they're actually happening continuously. And I'll just real quick show a little bit more about that, because this is one of the key capabilities. Intent is a high-level goal. That means it starts with the goals that people are making, business policy or IT policy or compliance requirements. That gets translated to precisely defined intents in the product using our intent library, which is, we make it easy for people to start with a template in the intent library and define it in a way that's relevant to their business. So for example, I think Terry asked a question earlier about, well, can I describe some sort of fence around the connectivity that should be there for data flow? And the intent verification for segmentation, for example, is able to do that. Say, okay, this should never happen, right? Regardless of whether there's flow there right now, you'll be able to understand whether it's possible, right? Whether you're actually protected from that potential vulnerability. And that's why it is a very powerful proactive capability rather than only a reactive capability. There's also system-defined intents that you'll see in the demo that are best practices that are there out of the box. And if there's any problem with any of these intents, they're being continuously mathematically verified. If there is a problem, it will generate an event, which you can see in the network map. You can see in a list, and you can push these out as notifications by APIs to ServiceNow and so on. So just to wrap up, what we think is really exciting here is that we're bringing together a comprehensive view of what is and what's possible. So understanding current data flow in the network, it's really essential. You need to understand application performance. You can use powerful ML-based techniques, as you saw earlier, to understand applications automatically using machine learning to be able to extract patterns from complex data sets. But along with that, assurance and verification is showing you what can happen, what's possible. And that gives a powerful proactive capability in intent verification, in troubleshooting and tracing back to configurations that are part of the root cause, and just visualizing, understanding for your team what is the overall posture of the network. Okay, so.
Wait, Brighton, before you get into the demo, and maybe this will be a nice lead in, but on a previous slide, you'd mentioned that it's also ingesting the configurations in addition to the MAC table, the ARC table, and so forth.
Yeah.
Will you be demonstrating, how that configuration ingest is being used by the product?
Yeah, so the model of the network is built with a combination of some information we get from the configs, some information we get from forwarding tables, like dynamically populated by routing protocols, for example. So there's different, depending on the device, depending on what APIs or commands it uses to extract information, we have to be opportunistic in getting that data the easiest way. Sometimes it comes from the config, and sometimes it comes from forwarding tables. So all of that feeds into the model that you'll see. It maybe won't be directly visible which part of that created the model until you look at the configuration state, that root cause configuration feature that I mentioned, where we can see, okay, why did the model think that this is going to happen? It's because of this, and it tracks back the reason that it had that part of the model. So you'll see a little bit of it there.
Okay, last question, then I'll let you go to the demo, because we all want to see the demo. Is there machine learning, pattern matching being applied to the configurations themselves that would help to identify errors in configuration? Meaning, I see that you have configured these 5 interfaces very similarly. The 6th one looks like it should be like these other 5, but you missed this one config statement, and kind of highlight that kind of a pattern discrepancy.
Yeah, that's a great question. We think there are many, many places that machine learning can be applied here. Right now, it's based on logical analysis. It's formal verification. You're saying this is what should happen, and it's going to show you any way that is not happening. But you're absolutely right that we think that this is a very promising area to apply machine learning as well, because there's many cases in networking. You saw it in flow-based application discovery, but also parts of the configuration where the world is complex. There are a lot of exceptions, but there are also patterns underneath those exceptions. And can you pick out those patterns? That's where machine learning is particularly powerful. So I hope we'll be back here in the future and be able to tell you a little bit more about that kind of technology. But at present, it's this part of the product is based on a logical analysis of the intent, and is it being met in the model.
Another question, Chris, here before we go on to the demo. The devices that are modeled, the non-VMware devices that are modeled, I imagine that has to be something supported specifically. I can't just throw my, oh, I've got this really cool, switch I bought at Walmart. Can you model it? So do you have maybe some examples? I'm not asking for a definitive list, but like examples of like what kind of vendor devices you model, and then if there's something you don't model, what's the lead time to get that done? Because it sounds like that's not something I would build. That sounds like something you would build and deliver to me. So is there a cost associated with that? Do I have to pay a one-time development fee? Is it just included in my support contract, etc.?
Yeah, great question. Well, we don't support Walmart switches yet, but we do support quite a wide range, and that's expanding. You saw a slide, I think, in Sesh's presentation earlier with the overall vendors supported by Network Insight. So, Cisco, Arista, Juniper, Palo Alto firewalls, also obviously, VMware, NSX. And that list is expanding. The assurance and verification piece is a relatively new addition. So parts of that are still coming in. You'll see that list expanding rapidly. We do have the full list on the website. So I'll refer you to there for that full list, unless Matt or Sesh, if you want to comment further on.
No, I think you got it right. I mean, the top vendors on the networking, you got them covered. The firewall vendors and load balancer vendors. Typically, that's 80% of what we see anyway, that NSX is attached to and networking is attached to. And then we do, bring in more devices as we progress along.
And then to the second part of my question, then what's the process for getting a device added? If I was like, do I just have to be a big customer and yell enough, or is there like an actual flow?
That'll help. Yelling will help. But yes, but I mean, I'll let Brighton talk about the logistic, the process behind adding it, because the way we get the configs are all different for different vendors. It's not just a cookie cutter, right? They don't have similar APIs. Even within Cisco, for example, different versions, different operating systems, different models, etc. So it goes through a cycle that we want to make sure that they're tested, validated before we claim support for it, for all the ACL rules and so on and so forth. Brighton, I don't know if I covered that.
That's a good
well
summary.
enough.
Yeah. It's not easy doing that, getting a rigorous, well-tested model of the functional behavior of these devices. So we're constantly taking feedback from our customers about which devices are important and putting them in the queue and pushing out new modeling capabilities with every release.
On that note, there are some that you may get as freebies. I mean, let's say, for example, Cisco 93XX, right? I mean, one of them supported, then probably that whole series will automatically get pulled and inherited. Yeah. But something completely outside with a different OS and so on and so forth, you obviously need to test it.
It's regarding the devices. So I understand that you concentrate on the core network, but the borders of the networks disappear more and more. I asked for the background from working from anywhere. So are there any plans to include consumerization, bring your own devices, consumer devices, the Walmart switches, etc.? I think it's not possible to make these lists then manually or add devices manually. There must be kind of automatism to detect new devices your consumers bring into the network when they work from home or from anywhere. Can you tell me more about that? Is there a plan? Do you consider that?
I'll take a stab at it, and Brighton, maybe you can add on. So there are two parts to this. There is a part of the product that is not specifically the network assurance and verification, where we can add a device through an SDK. So we do have an open SDK where you can extract through your config of that device and then get the config information that can be uploaded into vRealize. And then vRealize can at least show the configuration of that information, and you can go do your search queries and so on and so forth. So it is at least in your repository, and you can look at the health of the device. And obviously, since you're bringing the device, you probably might have to update that. So that part is available today, has been available for, I don't know, Matt, was it been a year when we had the SDK open for adding these other unsupported devices? Yeah. But whereas this functionality that we are talking about is highly customized, highly, because there are physical networks involved. How do they connect? For example, what are the network verification rules, the ACLs, the routing tables, etc. There's a lot of testing that goes through to build that out. Now, you mentioned about the edges. So whether it's a Cisco ISRs and the ASRs at the edge of the network, those would be modeled as we go along. But if you're bringing your own, your own third-party device and so on, the suggestion is to add it to the SDK, so at least it gets as a repository into vRealize, so you can see, what that device is doing in vRealize Network Insight.
So within Network Insight, so I just pulled up the actual network map here on the screen, and this is actually giving you a summary overview of all events that are occurring within the infrastructure, both virtually and physically. You're also seeing an overview. Now, when we say switches, we're talking layer 2. So this could be physical switches. It could be NSX logical switches, layer 2 logical switches within the infrastructure. From a routing perspective, again, that's physical and virtual. These could be routers. It could be layer 3 switches that are doing routing and so on. along with the NSX components. We also are showing an overview of firewalls, both virtual and physical, load balancers, the transport nodes. These are particularly obviously within NSX-T. And then we have other entities that we support and show within the network map. And then we have a legend down here that actually shows the various components that you can actually see within the actual network map, both virtual and physical. Now, the network map can be customized to any view that you want to do. And, you know, it's fully, you can zoom in on it to get details. So as an example, just kind of give an overview where you can create groups, you can group devices, give them names. You know, I've got my F5 load balancer, a Palo Alto firewall in there here, some backbone layer 3 switching combination. These are Dell S5248s. These are Arista 7050s. And then I've got, you know, some Nexus 9Ks as an example. So you get the same look and feel, but we could show all the correlation, both layer 2 and layer 3 within the actual network map. And then more importantly, tying that into, and let me just zoom out here a little bit, tying that into the ESXi host. So here I can see an ESXi host that is running NSX-T, and we're actually running PKS. So these are a bunch of tier 1 routers that are actually doing routing within our Kubernetes environment. And then I can see my tier 0 routers, and I can see things like my NVDS, my VDS that are running within each one of these physical hosts, that and how they're actually interconnected into the underlay networking. So very powerful in having that level of visibility and understanding and being able to correlate. But where the real power of assurance and verification comes in is, as Brighton mentioned, we're looking at a lot of different things. When we talk about intents, we have a long list of intents that are out of the box, and then we have user-defined intents, such as like segmentation failures or reachability failures. So as you can see here, these are all these alerts that are occurring that are either failed intents or things like best practices intents that we're actually checking on. So where I can see a port channel member mismatch, and it's going to show me port channel port 2000 is a mismatch between these two devices on Ethernet 8 at my New York distributed switch 1 and New York distributed switch 2. And it's going to give me all of that detailed information.
I haven't seen like routing protocol adjacencies in this list. Is that in there somewhere? This state?
Yeah, so they will show up in here. I don't have in this environment, I haven't set up any adjacency mismatch or configuration to but yes, we do support that, and that will show up. So all of that is incorporated.
Yeah, we also support BGP recently as well too.
Or well, BGP and OSPF. We support all routing protocols. So BGP, OSPF. Within the infrastructure. I think you're talking about with NSX, specifically NSX-T. NSX-T traditionally used BGP, but then OSPF support has been added also recently.
Since you said all routing protocols, I must ask ISIS as well.
You know what? That's actually a good one. And Brighton,
I can jump in here. So that part of the model comes from forwarding tables. And so various different protocols actually will write into the same forwarding table with the same format. So that picking that up actually does mean that any routing protocol that writes into that forwarding table will get captured in the state that's used to build the network model.
Sorry, are you only pulling the forwarding table or the RIB as well?
It depends on the device. And some of the information is from the config, some from RIB, and some from forwarding table. If the forwarding table is enough, then that's better because it's a smaller amount of state.
Yeah, I was thinking you could potentially miss out on some information if you didn't have like adjacency state, MTU mismatch type of situations, unless if you're getting that from somewhere else, CDP type of situation, but that's the reason I asked.
So,
yeah, we do pull interface states, CDP, LODP information. Yeah, there's several other information streams getting state off of the devices.
Is the built-in kind of best practices for networking intent rules like described in a data sheet? So somebody could look at it and go, oh, I use these 12 protocols. I can see, 12 of them are actually supported by this product right now.
Yeah, we have those detailed in the data sheet. So we have it correlated to every single vendor and the product and the models, and then what we actually support across those. So that we do have that inside the each installation and data sheet guide has that included, and we build upon that as we add new vendors.
Yeah, if that link could be shared at some point, directly, just so we can kind of get that out, I think that'd be very helpful.
Yeah. So like I said, I'm sorry, was a question?
Yeah, I have a question. Is there a way to tie all these config mismatches and config mistakes back to the applications and the intents that these applications are providing, so that I can actually tie it back to the applications that I'm servicing?
Yeah, absolutely. So because we have the visibility into the applications running inside the host and so on, these will correlate with the application. So that's a big expansion upon what the VeriFlow product did, focused on the network itself, the physical network. Whereas now, because we've integrated into Network Insight, we can correlate the virtual infrastructure and the applications all into the capabilities of the network map and the intents, and be alerted upon those. And I'll actually show some of that here in a second here. So I was just kind of going through really quick and just kind of showing, obviously we're looking at various different events that are occurring within the infrastructure. Even things, if I see an underlay device, LLDP neighbor being removed. This is a Cisco UCS chassis we just removed out of this infrastructure. And I can see on the Nexus 9K, it lost its LLDP neighbor relationship. So I can, we're looking at pretty detailed information. We also show all of the entities within the infrastructure. So these are going to be everything from physical devices to virtual. So I can see, like an example, the ESXi host and the virtual distributed switch that's running on it. I can see hosts that have NSX devices such as NVDS, tier 0 router, tier 1 router on the host. Or I can even come in and simply search and say, I want to look for an IP address or a specific entity. I can type in, for instance, even a vendor name and hit Cisco, hit enter, and now I can see my Nexus 9Ks and some of my UCS FEXs. So if I click on this, it'll snap right to it in the network map. And then I can even look at, different, my Ethernet interfaces to see these are all these interfaces are offline. This one lit up green, this one that's online. I can click and get the configuration and look at the information along with what is it peered to, in this case, on the other Nexus 9K, to look at from a configuration standpoint, what VLANs are configured on that switch port. So a lot of detailed metrics. I can then also go to the path section, and this is where I can come in and I can model anything from virtual to virtual, physical to physical, virtual to physical, where I can come in and I can specify a source. So let's say I want to check and see if I have any type of path or routing availability or segmentation in place, specifically with an application. So I can go in and I can say, I'm going to use my demo app here. So I'm going to use my app called Nav, and I'm going to choose just the level 1 VM on the web tier. And I'm going to check, as an example, to my database and the back end. Now, typically, I wouldn't want to have my front end being able to have access to my back end, so I'd want to have segmentation on that. We can also check path availability by adding hops, so we can specify specific hops. And then we can also filter down if I want to check on specific source and destination ports, protocols, so I can choose specific protocols that I may want to focus on when I'm doing searches. The path type, which could be the primary path, with the ECMP, backup paths, or just all paths, along with bidirectional or just forward traffic. And then I can also filter down by the status, whether show me all paths, only reachable, or only blocked. So now when I hit show paths, it's going to go through and it's going to analyze for all the configuration data, virtual and physical. So now I can see here that between my source VM, which is my web 01 to my DB01 and my application, I have 4 possible paths, but I can see that all these paths are blocked. And when I click on these and actually slide this over some, you can actually see the dotted lines on the network map between the 2 ESXi hosts, the NSX components, the underlay routing that it's going through. It's actually this is doing layer 2 connectivity. But I can actually see kind of like a trace route on steroids, where I can see hop by hop, you know, where I'm starting at from my source, the VM, this is my source VM, the IP, the MAC address. Then I can see here that this is being blocked. You see the blocked indicator, that there's an ACL in place that is actually blocking the path, not allowing web to talk to DB. And if I click on any of these are all dynamic, this will actually show me that information. So here I can see the actual ACL, and this is actually an NSX-T firewall rule, where I can see the source, the destination, the action that was defined, the rule ID, all of the information that's correlated to that configured rule, where it's applied to. And then I can, if I had multiple packet headers, I can also select to see that configuration data. So we'll provide all of that detailed information, not only for the NSX components, but as I'm going through and seeing, you know, the in and out interfaces, whether I'm using layer 2 or layer 3 forwarding, where I'm changing, and actually the packet header changes are occurring. But as I actually encapsulate the data here, coming in on the layer 240, I can see here that I'm encapsulating on VLAN 2004. These are my source and destination IPs and my underlay. My port, it's utilizing Geneve on port 6081. Here's my virtual network identifier, 67665. Then as I go further down, I can actually see, as I come into my underlay switch, this happens to be a Dell S5248. The in interface, it's being layer 2 forward, the out interface. And as you guys were talking about configuration data, if I click on, for instance, this Ethernet 11231 in this specific path, I can choose, you know, between packet headers, and I can also see which commands we're running across the devices to pull specific data to correlate and be able to build out the map, the pathing capabilities around what data we're parsing to be able to determine the availability specifically. So this is actually coming from that device that we're actually running from a collector standpoint. So you'll see hop by hop again. This will go all the way to the destination. And then the other thing that what we do is we provide you with an overview of.
Hey, Matt, we just have about a minute. Thanks.
Okay, thanks. So we also will show you, notice this is a dotted line. So this is because the traffic is blocked, and then the arrows are indicating the traffic direction capability. But we're also showing you the note here, if allowed, traffic would continue as follows. So even though this path is blocked, we're still doing all the analysis and showing you that if you were to remove that ACL, this is the path the data would take for, you know, the specific path of interest. And I can look at that for all possible paths.